pleasure to be here tonight. Actually, I was going to have them open too with a rock song for me. Pat Benatar, hit me with your best shot, but we decided not to do that tonight. Well, again, welcome to be here. This is the title of the talk, How to Write a Comprehensive Geotechnical Report. And what does that mean? Let's see. Is this supposed to click?
It should.
Get this one here?
Yeah.
There you go.
There you go.
The word comprehensive, covering completely, inclusive. You know, one of the things about word geeks, you start looking at words very carefully. Cover completely. That's like, you know, the fullest extent of the law. There is nothing more than covering completely, right? So you have to ask yourself, do you cover everything completely in every geotechnical report you write? I would suggest maybe not. But as the announcement said, this presentation is a compendium, a summary of my experience and training as an engineer, my mentoring as a young engineer, my collection of articles, columns, and books on business and engineering and technical writing, which I've got many of them in my briefcase, or actually a box in the back if you want to come look at them later. Then my experience is providing expert witness services. And as we get deeper into this, virtually every point I make will derive from a case that I have involved myself in or have been involved as an expert witness over the years. So this is something that when I came into the engineering world, in the matter of litigation, it wasn't there. Today, you put a period in the wrong place, you can get sued. So here's a question for you, a couple of questions. How many of you have degrees in civil engineering? Okay, anybody here with geological engineering? Okay, and then what about anybody here with geology or geophysics? Okay, so it's going to kind of cross or come across it. Because in Minnesota now, for example, all three of those fields can get registered and then write geotechnical reports. As a matter of fact, in Minnesota, you can be registered as an agricultural engineer or soil scientist, write a geotechnical report. This one kind of baffles me a bit, but nevertheless, that's what the law says. Okay. Here's another question for you. Did any of you here receive a basic instruction on how to write a geotechnical report in any part of your college career, BS, MS, or PhD? I see one hand going up. I see one kind of going up. There aren't too many schools that will have a professor who will teach that. I understand there's a professor at North Dakota State who teaches it, one at Ferris State University in Upper Michigan. Greg, where did yours from? What, Marshall Silver or what?
University of Texas.
Say again?
University of Texas.
Okay. And then at Marquette in our senior year, we had to write a basic soil report. And it was basic, but it kind of taught us the fundamentals of this. And then you get thrown out in the real world, and there you are. You're starting to get involved in writing reports. So there's some things that are really important to know. When you're writing, you must write well, you must write clearly, that is not ambiguously, and you must write correctly, okay? And that's not always the easiest thing to do. I mean, in the geotechnical world, we deal with concepts which many civil engineers do not understand. Architects certainly don't understand them. Construction managers may not understand them. Structural engineers, maybe yes, maybe no, understand them. But these are important concepts to understand. And you have to remember that good writing is the projection of your credibility. Good writing is you when you're not there physically present as the reader is going through your report. So if you do write not well, or if you write ambiguously, or if you don't write correctly, correct word usage, things can be misinterpreted. And studies have shown, ASFE did a lot of this reviewing, things that are not understood well can lead to litigation. And again, as the years go on. Oh, by the way, did you know as PEs, did you know you could be personally sued if there's litigation on a lawsuit where you wrote a soil report? Did you know that? I see a few heads nodding. Did you know that you can be sued as a PE after you've died? I mean, if your estate has the wherewithal, there have been suits filed against the estates of dead engineers under construction litigation. I don't say this to scare you. I'm just saying these are the facts of life that we probably weren't told about when we went into engineering those many years ago, right? Okay. But spelling, grammar, word usage, sentence structure, avoidance of the passive voice, proper parallel construction, subject-verb agreement, proper use of numbers, punctuation. These are things you might have heard back in what, 4th, 5th, 6th, 7th grade from your English teachers, and we all rolled our eyes and said, what do we need that stuff for? Well, Remember, geotechnical engineers, as a branch of civil engineering, we write more than the other branches do. You know, the civil engineers, they get their spec written and they'll have the same grammatical errors in that spec 10 years later. We engineers don't dare do that. We have to make sure that our writing is correct, easily understood, and having been written correctly. From among the people I associated with over the years has been John Bachner from ASFE, and then John Dunnicliff. If you know anybody involved in instrumentation, they know the name John Dunnicliff. He's written articles about writing for geotech engineering. Steve Wilbers, a professor at the University of Minnesota, who was not, he was a professor of English, but he wasn't in the English department. He's attached to the law school and the Institute of Technology, written books and columns and articles about business writing, proper business writing. I've met with him. At one time when I had my company, I had quite a few of our engineers go through one of his classes on writing. These are important things to know. So from Professor Wilbers, well, first let's go back to spelling. John Bachner writes an article, perhaps you've seen it in the Geostrata magazine, the Geocurmudgeon. He'll write about the art of writing and marketing within the geotechnical engineering profession. Now, there's a test that goes at the second page of this. It's in my handout, but I'm not giving you that now. I want you to either sit, take notes, or listen. You get the handouts. You can go through the quiz, a spelling quiz at the end of this. And there's some other books out of my collection. My wife looks at me and says, geez, what a geek. She said, you keep these books. These are hard copies. These are not, on the internet. But right. This was a course that ASFE gave that John Bachner developed, right. It's an 8-hour course or 2 4-hour courses, how to write correctly. And then 5 easy lessons in clear thinking and writing by Steve Wilbers. And he goes through these things. So the 5 elements of effective writing: a central idea, organization, expression, spelling, and grammar. And I would venture to say that probably in your training on how to write a SOL report, nobody ever sat down and specifically addressed how you should write a SOL report in this context. Would I be correct in saying that? Yeah, I'm getting mostly nods. Okay. So this one is included in your handouts too. Okay. Now, another thing I suggest, and this now we're getting to one of the generational differences here. I would suggest, particularly earlier in your career, that when you are going to write a report, write an outline first. And this very day when I do my expert witness reports, and my expert witness reports are generally longer and denser than a geotechnical report is, with less setup of format. But I'll write an outline first to organize the thoughts. And I would suggest you consider doing that to get your thoughts organized. I don't mean a table of contents of report. I mean an outline on how you're going to go about it, so you get an order and a logical sequence. Another one, there's something going on today. I know it started probably, 20, 25 years ago, the template report. Hey, kid, you don't have to think. Just change the address and change the name of the job, and we'll have one of the principals look at it. Get done real quick, right? So one of the reports I remember reviewing that was a templated report. The engineer had a very nice discussion, about 3 pages of the basement design, perimeter drain system, vapor retarder, backfill, lateral earth pressure. I said, that's really a good section, except when you described the job, you said it was a slab on grade. Why are you talking about a basement? Oh, I forgot to take it out. Well, the corollary question that becomes, what did you forget to put into this report? And we'll touch on that later. Okay, going on, the first step in writing a good comprehensive report is a good proposal. You look at the proposal, Kwasny, what does a good writing have to do with your proposal? And how does the proposal lead to a good comprehensive report? The proposal sets the stage. Believe it or not, a proposal is a legal document. It sets the stage for your legal involvement as an engineer and for your company's involvement. It sets the scope of service. And if you've ever had the fortune or misfortune of getting involved in legal situations, these things become important, of doing what you define you would do and having it properly defined. It's a lead into your opportunity to write a good report in your proposal. So don't treat it lightly, okay? Remember I said of all the documents, when you're going to write well, you're not going to do it just for the report. Everything else leading up to the report has to be written well too, marketing letters and your proposals. And one of the elements, to me, I'm going to use the adjective here, it's imperative that you have a sound understanding of a project. And I'll tell you, one of the things I've seen in so many cases involving litigation, there was a geotechnical engineer said, we assumed there would be light column loads, or we estimated the column loads. Somebody tell me what the column loads in that building might be. Have you ever designed, anybody here ever designed one of these? My wife calls them the ugly apartment buildings. Okay. If you've not designed one, do you really know what the column loads are? Or how about this? By the way, none of these pictures are of jobs anywhere near here. They were taken on my trip down to Arkansas last week. But this is a museum being built. And the space from that column to that column I measured off is about 90 feet. These here are about 25 feet. Do you think those columns might have a higher load than ones that are only 25 feet apart? Do you know what they are? Heck, it's only a 3-story steel frame building. I mean, we'll just estimate the column loads. I'm going to tell you the way to do this here. Call the structural engineer and the civil engineer and ask them, you know, what are your maximum column loads? I mean, we don't have to know whether it's 246.7 kips or 247.8, but we do have to know whether it's 240 or 275, just to do your settlement calculations, okay? But ask them what the loads are. And then my next step after that is when you write your report, you put the structural engineer's name and the date on which you spoke to the structural engineer. And I'll tell you why. Everybody puts at the end of the reports, if there are any changes or if there are any differences in our report from what is really happening, what do you tell them? Please call us. Everybody who's ever gotten a call like that, raise your hand. Not too many. Oh, you got one. You've gotten a call from that? Well, I'll tell you, there was a young engineer. It was one of my fellows I knew at AET. A couple of years back, he was involved in a project over in Wisconsin. I had been asked to write the soil report for it, but I wasn't doing soil reports. So I used AET, and he knew how to do this. Put in the soil report in addition to a wastewater treatment plant. And in the report, he put in the structural engineer's name and the date, gave all the elevations, the loads. 3 or 4 days later, the structural engineer called him and said, I gave you the wrong information. And here's the, we got paid, by the way, to go back and rewrite the whole. Yes, sir.
I see a lot of times nowadays, you get that there's a chart essentially in the beginning of the geotech report.
Yes.
You have assumed loads.
Okay.
Because we haven't been given that.
Yes, I'll address that too. Okay. There's a way of addressing that also. And you have to explain that to your clients on that. But what I'm saying is a geotech, unless you've done the design for structures like this, or maybe how many of you have done a 500,000 square foot warehouse? Have you asked the questions? Are there going to be any second, balcony level storage areas? What are the rack loadings in that warehouse? These are things that we as geotech should not be assuming or estimating. Ask them for it. And if they don't have the information right away, if they say it's because oftentimes we're working in the preliminary stages of a job, put that in your report. The best information available as of the date of this report is that the loads will be such and such. The structural engineer, Jim Bob Smith, PE, SE, told us there'll be refinement. We should be contacted to write a supplementary report on that basis once the final loads are given. But people they'll lead geotechs down the primrose path in this, I tell you. And well, you're just geotech. You don't have to have the load, just write the report. I've heard that before in my career. I mean, things like another one you don't know in a warehouse like this, what the live flow loads will be. And I'll tell you, from one of the cases I was worked on, there was a warehouse up in the metropolitan area here. Nobody here had worked on it, okay? None of the geotech firms had worked on this one. But the company moving in was to call it paper converting company. Take big rolls of paper and cut them into sheets for brochures and stuff like that. Their flow loads were 1,700 pounds per square foot. The day they were moving in, they broke through the floor slab, okay? Because I guarantee you, a real estate agent, if a potential industrial lessor comes in and wants to rent 250,000 square feet, they'll just tell them, sure, the floor loads can take anything you put on it. And the real estate agents don't know squat about whether or not the floor loads, whether that floor can take it. They don't know the thickness of the slab or anything like that. But don't let yourself get trapped into making some assumptions, because if you know it's going to be heavy floor loads, you're going to go about preparing the subgrade differently. That's right in your report, even though you don't do the structural design of the concrete slab. But again, it's a geotech. Don't get caught making assumptions or estimates for things that you don't personally have experience in doing. I mean, and so you may have to push the client to get you that proper information. Have I addressed your question on that one? Or do you have to go back and let them know this?
I guess I was asking for more about when you're talking about getting legal ramifications as a ground contractor. I see all the time where we get Yeah, your budget.
Yep.
And it's based off, I either have to take, calc out loads from a preliminary schematic structural design that has no commentary on loads, or I have to take the assumed loads from geotech that say, I think this is 200 kips per column load. And those two numbers generally don't jive, right?
The thing to do there is put that information in your report. But this is what we were given.
Right.
And then we have to follow up after that. But don't let yourself get trapped in saying, oh my gosh, I have to serve this client. So I'm gonna take a guess at what it is. Or using these words like lightly loaded or a few feet of excavation. Like, that really doesn't cut it in terms of being comprehensive. But you have to know, and here's another thing too. And I'll admit that within the geotechnical world, there was more to know today than it was 30, 40, 50 years ago. But things like how, as a geotechnical engineer, especially if you haven't done structural design, how does a wood frame building react differently than a steel frame building to settlement and to loads? These are things that you got to incorporate. You don't have to be the structural engineer to design it, but you have to have an appreciation of how the building reacts differently based on the recommendations that you give in terms of ability to tolerate settlement, for example. Okay, so I say assume nothing. That's the buzzword here. Assume nothing about this. What are the first floor loads, the first floor and basement elevations? Again, don't just say several feet, or there might be some cutting and filling. Get it as close as you can based on the information they have available. Okay. Ask for the traffic pattern in terms of daily traffic passes, types of vehicles. Here's another thing. You want to know how close is the project to an interstate highway. Do you know why you'd want to know that? Well, interstate vehicles are allowed heavier axle loads than are allowed on normal highway, state and local highways. And it's my understanding that these loads are allowed to be driven up to half a mile away from the interstate. Okay. So if they don't design the pavement well enough and they drive these heavy interstate loads, and wink, wink, do you think a few interstate trucks are overloaded too? Yeah. And they drive on a pavement that you perhaps gave the recommendations for and doesn't work, you could be sucked into that. So you want to mention that in your report, that this site is located in such a location and could have heavier axle loads driven on it. When you get to the drilling program, I think it's important to let in your proposal to mention who set the drilling program. Was the drilling program set that met your needs as a geotechnical engineer, or was it done just on a cost basis? And here's one thing that gets a little bit risky to say. There might be clients who want the job done so cheaply and so poorly from your perspective, you might sometimes have to walk away from a client. And there are ways of doing it without insulting a client. For example, just make sure your price is so high that they won't take you. But you still respond to their proposal, okay? And let the other guy get the job. Okay. Laboratory testing program, who decided on that? I mean, just the blow counts alone are often not enough. You want things like moisture content, or in more complicated cases, you may be going to triaxial testing, things like this. And then the final thing I want you to do, ready for your proposal. How many here have ever read ASTM D420? Raise your hand. Really? That's your assignment, one of your assignments here. Read ASTM D420. It's how to plan a site investigation. Okay. And among the things it tells you is there should be a site reconnaissance done. You should review the USGS quad maps, both the new maps and the old maps, so you can see differences on a site. U.S. Department of Agriculture soil maps, both the old maps and the new maps, to see what was there before it started getting developed. Okay, but read ASTM D420. It's a very helpful thing that will help you plan your investigation. Okay, when you get out there and you start drilling, make sure your instructions to your crew are consistent with what you are planning on doing. If it's if we're talking about a Burger King, a couple of 15-foot, or no, 14.9 feet, right? You don't want to go past 15 feet in Minnesota, 14.9 feet. Could be good enough. But if you're going to, for example, a building with the basement down at 16 feet, I would submit to you that 5-foot sampling starting at 10 feet is not adequate, because that's the zone, the zone where your footing is going to be stressed is somewhere between 16 and 25 feet. Why not go to continuous sampling in that zone? Might cost a little bit more. I'm telling you, you'll get more information in the zone that you need it as an engineer to analyze what's going on. Skip sampling like that at 5 feet, you can begin to miss layers. But if you're doing continuous or 2.5-foot sampling, it's a good chance you'll catch things that you should know about. Okay, and the boring layout. I've seen cases like this too. Make sure when the boring layout is done that you refer it. I know the tendency today is to use the GPS systems, right? Just walk through and click and hit a button. But make sure that you can relate your boring locations to known landmarks so that they can be the locations can be reconstructed if necessary. Plus, just putting these coordinates on a map doesn't necessarily tell you where the boring got drilled. But here's another one, shooting elevations. Do not shoot elevations to arbitrary benchmarks like a top of a curb, which can be removed before the construction is even started. Do not shoot elevations to the floor slab of a building in the middle of the site that's going to be demolished as part of the construction. Do not call a benchmark plus 100. Get it down to a city datum, a state datum, USGS, something that could be reconstructed. Even if you and the civil engineer got hit by a bus the next day, they can go back and figure out what the elevations of those borings were. Again, I'm talking about cases where these have come up in lawsuits where just poor quality surveying of boring layout and boring elevations were done, which did not allow a comprehensive report to be written. Okay. And one quick thing before we get into some of the details is the matter of to writing. I'm going to talk about, I'm going to go to this one here. Oh, right here. Go to the first one and come back to it. The GBA, that's the successor firm to ASFE. It's now called the Geoprofessional Business Association. In-house guide to review of geoprofessional reports. Ooh, there's more to it than just checking the address of the person to whom the report is being sent. And here's one important thing to remember. When you write a report and you write it comprehensively, you cannot reasonably expect the reviewer to catch all your errors or all your omissions. That's not the intent of that type of review. It's physically impossible. It's up to you to go back to the write well, write clearly, do not write ambiguously, so this review can be done. Okay. So now we're going to get into the details. Be a professional, write one. This is one of John Bachner's columns. They're just great columns. I mean, this one's from 2013, 10 years old. Holy crap, March of 2013, and it's still pertinent today. Okay. But the geotech must have a broad range of knowledge of the soils, of the earthwork operations, and the foundations, the pavement. And sometimes if you sit back and try to analyze how much do we have to know, it can get scary. There's a lot out there that you weren't taught about in school. And depending where you're at in your career development, you may not have encountered yet. And yet the client is expecting you to know that. So that's a process that has to be worked out. Okay. So first of all, I can go back, write an outline. Describe the project in detail. These are all in your, these are some of the books I've got too again. By the way, I've also used these books to win bets with people about proper punctuation and grammar. There's some obscure parts about American English. For example, when you're quoting something in American English, do you put comma, quote, or quote, comma? Well, in British English, you put quote, comma. In American English, we put comma, quote. Okay, they're both English, but there's differences in how the punctuation is done. So you got books on Punctuate It Right, the Grammar Bible, the In-House Guide. But now we're going to get to writing the report. Okay. Now we're at the rubber meets the road. So describe the project in detail. I mean, it doesn't have to be 45 pages, but give the column loads as best you understand them, explain how you got them, explain who gave them to you, give the date on which you were given that information, and repeat it. Okay. Explain the soil boring program, tell who planned it. If the client insists you're going to drill 5 borings, say that, XYZ Development, John Smith of XYZ Development specified we would drill 5 borings on the site. It's out there in the public, let it be known. Or if the structural engineer specified, I would say who knows better on how to plan a program than a geotechnical engineer. But if that's the way it's going to go, make sure it's clearly explained in the report. So the responsibility for that is assigned to the appropriate parties. Same thing with the laboratory soil testing program. Okay. I'll tell you, there were times in my career we had clients who didn't even want to do any lab testing. And I knew we needed moisture content tests because it's all clay site. And I'd run the test, wouldn't even charge them for it. because I knew that that was needed to help analyze the situation on the site. Present the groundwater level readings and describe any bodies. Here's another one. Early in my career, I was told Kwasny, any body of water within 1,000 feet of the site, you make sure the drill crew shoots surface elevations on the water. Okay. This information goes into your analysis of where the groundwater table is. I'm just talking with some folks here this evening. I've been called into a job in Madison, Wisconsin, where there's a project. None of you are involved, not even involved. There's a building about 2 blocks of state capitol between Lake Monona and Lake Mendota. It's got 2 basements in a 14-story apartment building, and the lowest basement is 10 feet below the water level in Lake Monona. And they're pumping 200 gallons a minute out of the excavation to keep it dry. And I got a call saying, "Can you help us out?" I said, well, the first question, I said, if you're pumping it to keep it dry, what are you going to do after you get done? You think you'll have to keep pumping then? Do you have the permits to pump that water out? Okay. These are the kinds of things that a geotechnical engineer, not saying you have to do the total groundwater analysis. Oh, by the way, at the same job, found out there's been no analysis done of what pumping 200 gallons a minute from around that is going to do to the buildings around that site. You think there might be some settlement going on of streets and sewers and adjacent buildings? This is part of that comprehensive report that we as geotechs know about, but it's unlikely that the structural, the civil, the mechanical. I often wonder, why do they have mechanical engineers design perimeter drain systems around basements? But that's a whole other class. Architects, construction managers, we are the professionals who are expected to know about that. Explain the soil conditions, then give you recommended foundation types and design parameters. If it's a simple footing foundation with bearing capacity and settlement, fine. But one of the other things I was taught early in my career is Kwasny, the recommended bearing pressure may be the least important part of the report, half the reports you do. There are going to be other elements dealing with groundwater, soil disturbance, constructability, things like that going on. Okay. For a basement, discuss the perimeter drain system in detail. And then if you have a basement, it'll permanently be below the groundwater table, which is not uncommon in industrial applications, especially. You're going to have to tell them, what about waterproofing, designed to reduce hydrostatic uplift or tie downs to keep that basement from floating out of the ground. This is something that not that you have to design the tie down or design the waterproofing, but as a geotechnical engineer, you're expected to know the principles of that. And this will help keep out of trouble. Review the basement backfill and lateral earth pressure. It's amazing how I've seen soil reports that simply do not address the lateral earth pressures. They give values that are way lower than what really should be. Well, that's what the client wanted. Well, so what? If the client wants to be cheap and doesn't want to do things properly, you have, and by the way, this is not just CYA saying do this. This is what the proper engineering is all about too. Okay. Describe the soils forming the pavement subgrade. Oh, wait, I'm going to touch the final grading around the exterior of the building. Should be slipping, what, 6 inches in the first 10 feet typically. And if they do a poor job of compacting, it'll slope back. And they say, but the gravel on the top is sloping. Yeah, but the gravel, that's just like putting, gravel in a bathtub. If you let the fill slope back toward the building and they have water problems. But describe the soils in the pavement subgrade and give an appropriate diameter. If the soils are frost susceptible, you should be discussing whether there be some load limits in the springtime. Okay. At least up here in the springtime. Is that going to come this year, by the way? Or was it like that today? I don't know. I had projected we were going to have snow on the ground until Memorial Day, but but there is some snow coming this weekend again, right? So we'll get back to it. But these are things, again, to discuss. Not that you have to come up with a total design for it, but to discuss it. Discuss the embedment of the foundations for frost protection. And this is something that a group of us engineers have been arguing with in the state of Minnesota for 30 or 40 years. If you look at the map for frost embedment, they have 42 inches. And maybe that's good for heated building. And maybe it's good for the days before they started put energy insulation on the outside of the basement walls to prevent heat loss. Okay. But that does not apply, especially for foundations remote from the building, deck foundations, canopy covers, things like that. And yet contractors will insist on putting them down when we know that you get away from, depending on the snowfall, and then when the first temperatures hit, you can get frost down in those areas 7, 8, 9 feet, which can lift those piers up. But you as a geotechnical engineer, I'm sure you'll be blamed for that if that happens. Okay. Another one, frost susceptible soils for exterior subgrades. Give recommendations on how that can be prepared. And I would tell you, don't give an option for this. or don't let the civil engineer or the construction manager figure out how to do that, because they'll do it wrong. They're going to look at the cost of doing it as opposed to the application of doing it. You know, digging it all out, putting non-frost susceptible fill in, or if you do it exactly correctly, you might be able to get away with partial excavation and use of insulation to prevent frost penetration. Some new techniques coming up with, if you're familiar with Wurzbo, heating coils under exterior pavements with hot fluid in them, or there's some, even some work being done on using electrical cables to prevent frost penetration. But, oh, ASTM F1637, anybody ever read that one? It's an ASTM standard on tripping hazards. And you get half an inch of deflection and you've got a tripping hazard now. And then you get some geeky expert who comes up there and points this out and says, that soil engineer should have known that. That can now cause a tripping hazard. So read that, another ASTM standard for you to read. One of the questions you should ask when you're discussing how the job is to be, what the elements of the job are, is whether or not it'll have a retaining wall. They'll often forget to tell you that. And you won't know about it until it's under construction. Ask if it'll have a, just ask it. One of the reasons there's more and more bad sites being used, they have to put up retaining walls in order to make the site usable. Ask the question, will there be any retaining walls on the site? And then you can bring up the fact that, particularly if it's an SR, segmental retaining wall, NCMA, National Concrete Masonry Association, their manual calls for soil borings along the wall. And yet so many developers don't want to do that. And the wall contractors won't have them done. And so the design engineers are assuming soil conditions along the walls, but the manual defines the need for soil borings along the wall. Okay. Well, this is a whole lot of reading assignments coming out of this one, isn't there? Okay. If you find groundwater conditions will affect the construction and post-construction performance, and mention that, bring that up in your report. Again, it's not up to you to design the dewatering system, but a good geotech engineer, an experienced geotech engineer should be able to say, in our opinion, that the site will have to be dewatered with well points or with sump wells or deep wells or something like that. Because if you don't at least give an indication of an appropriate way, the contractor will try to use the least expensive method, pumping from sump pits, which could lead to soil disturbance in the base of the excavation and the base of the trench, but give some indication. Coming to the end of the report, discuss applicable and recommended observation testing procedures. I would suggest that you not just say there should be density tests around the field, give a specified one test for every 2,500 square feet for every 18 inches of fill placed. If you're writing a report dealing with stone columns, for example, have any of you ever done that? Soil modification, soil improvement. I know that they don't want me to mention stone columns. Okay, but I'm going to mention it anyway. But an important element in building stone columns is to know what the diameter of the column is in place. And if you don't keep track of the volume of rock going into each stone column, you'll not be able to tell what the volume, what the diameter was. Okay. And I'm working on a case like that right now with the soil engineer recommending using stone columns, and that was all they said. And the contractor now, with the part of the building settling, I'm pretty certain they did. Well, I know they did not keep track of the stone columns because they gave us all their daily field reports. All they kept track of when they have a rotating vibrator, they check the amp meter to see if they got the right amp, so it was rotating right on compacting aggregate, but they don't know. They don't have a clue how much went in each one. At least they can't tell us. And another one is constructability issues. Discuss the possibility that vibrations from pile driving could damage an adjacent building. Okay, for example, in the city of Minneapolis, where they've had quite a few vibration problems over the last 10, 12 years. It's part of the city code that when the developer or the architect, whoever's going to do it, puts in the application for the building permit, they're supposed to have a letter from an engineer familiar with the retention system design, assessing whether or not potential vibration damage could occur to an adjacent building. And in many cases, that is not being done. But in cases where they never had the engineer turn in that letter. But you should mention it if you think, but this, again, if you've not done projects where vibration damage causes, or rather vibration of the soils causes damage to adjacent buildings, this is something you have to learn on. And I'll tell you, one of the tricks here is that the vibration damage to building can occur even over medium dense sand soils. You think of it typically as being on loose soils, it can occur in medium dense soils too, depending on the frequency and the magnitude of the vibrations. We didn't learn too much about that in school, huh? Another one happening today, now there's even textbooks being written on this. If you have cranes that are parked too close to slopes or walls, those can cause constructability problems. One way this has been addressed in the city of Chicago, if an engineer is writing a report, a soil report for a building that will have a basement, they have to address the issue of cranes or concrete trucks parking up against a retention system or a basement wall right in the soil report. So there are entities beginning to assess this. This is stuff geotech should know about and get into the report. That's the type of thing that makes a comprehensive report. As I said, everything I've talked about here, I've come across in litigation. And I don't want my friends and acquaintances and people whom I know in this profession getting involved. But I'll just tell you, the litigation world today is different than it was 40, 50 years ago. I mean, when I came in, litigation against a soil engineer was a pretty rare thing. Now, at the drop of a hat, everybody gets drawn in. And it is so easy to come in and say the soil engineer did not do this or did not do that, or should have done this, should have done that type of thing. And you've got to make it part of your own education to broaden your experience. So like one of the things that I would suggest you be looking at in terms of writing comprehensive reports, you notice the first part I concentrated quite a bit on these books and articles and columns about writing. Some of these are in the handout we're going to give you here. Pick those books up, read them, learn about them, learn proper punctuation, spelling, grammar, the proper way to use numbers in a report. There's one thing I know, it just galls the living daylights out of John Bachner. You see a soil report. We drilled 18, parenthesis, the numeral 18 borings on 25 acre, parenthesis 25. That's lawyer talk. That's not engineer talk. Okay, that is not needed to make a comprehensive report. Matter of fact, it just mucks up the report. I'll tell you that right now. That's not a proper way to use numbers. But where to use hyphens, when to put a hyphen between a number and a word. These are the details that go into that smooth writing, where the people look at that and realize, even though you're not there, saying, this person really knows how to write. I mean, this is all proper writing. And it's more easily understood too. Okay, that is what I've got to say for tonight. I'm open to any questions, any brickbats, anything you want to throw at me. Yes, sir.
Wildly open-ended question.
Okay.
In today's day and age where we have all GIS systems.
Wait, just let me come back a little bit. I'm still,
Okay.
now I've been on too much rifle fire, too many pile drivers and drill rig engines in my career. I'm waiting for my
In today's day and age where we have all these GIS systems, we have essentially mapped,
yes.
particularly in a metropolitan area.
Yep.
We know you're going to drill in Plymouth, you're going to drill in Inver Grove Heights. You know, to a degree, what you're going to get into. Not necessarily, but you have an idea.
Yep.
You have a prescribed loading scenario from a structural engineer.
Okay.
Hopefully, when you're putting together your reports. Can you just speak on where you're drilling, with what loading you have from your structurals, what type of lab testing you should prescribe or you should propose based on depth of settlement bulb, all of that, what you're gonna bring value to with your lab testing, not just to do lab testing to do it.
No.
But where are we bringing value by what load test, what lab testing at what depth, and the frequency of said temperature.
Oh, question will take a half an hour to answer.
Said it was wide
Okay.
open.
Let me answer the first part of it, because it's really a good one. The first thing you should do within your own company, if you get an assignment on a given site, if the company does not have a log kept of all the jobs they've drilled and where they're located, go ask one of your senior colleagues, have we ever done anything at the corner of First and Main Street? I'll tell you, there was one job in Minneapolis where went into a lawsuit and the geotech firm was involved, and they had done the project right across the street that had problems, and the Rogers did not know about it. Okay. That's a part of the site reconnaissance for 420. ASD and D 420 says you should also inquire about borings on the site or adjacent sites if your client has them. That's part, there's parts, there's bits and pieces, no one answer all the way. That gets you going to start with. One of the reasons for looking at the older US Department of Agriculture maps, I'm aware that they have them online today. What they do is they overlay the soil types on today's topography and today's development. What you want is a map that was done 60 years ago, before that wetland got filled in. So you can say, damn, this site was a wetland back in 1964. Okay. But I know what a lot of companies have thrown out their hard copies of the USDA soil maps. So, I mean, that's why I'm saying the generational differences come into play now too. But those old maps, you can, I did this, I tell you, on one of the northern suburbs, I looked at a site and pulled out the 1964 soil map, and 2/3 of this building was in a swamp and was not even mentioned in the soil report that was recently done. But doing everything you can to get the older historic information, how a site was developed or what had been there beforehand. Those are helpful parts. Am I addressing the question for you, at least the part? Okay.
I've seen before where as a geotech contractor, you get lab testing that's in a geotech.
Okay, I'm going to talk about lab testing.
Based on what the building is going to be, no offense to anybody in the room, as a geotech engineer, that the lab testing is essentially doesn't bring any value to me as a geotech contractor. But when you're looking at, you assume that from a drilling to Plymouth or drilling to Crow, wherever you're drilling, that I'm going to hit a soft layer of some weak clays, probably in the 12 to 20 foot range. I should do some sort of testing in that grade versus stuff above the crust or stuff super deep. These are the weak areas. This is the area that's going to cause issues for the site. If you don't know it going in, but if you have a general idea based off of that, I'm just curious.
Okay, I'll give you one of the rules. Here's a rule of thumb that I was taught early in my career. If it's got any more P200 than a silty sand, run a moisture content test on it. If there's any one test I would want on any site, you said, Kwasny, you have one test, pick it, you do a moisture content. It'll tell the earthwork contractor what he has to do if he's going to be using this stuff as compacted filler clay. If you get to know the soils and the glacial geology up here, and I have to mention a word about geology too. Kind of a rule of thumb, if it's a low plasticity clay and has a moisture content less than 23%, you can probably put 3,000 pounds a square foot on it, just by knowing the moisture content. I don't care what the below counts are. How's that for an answer? But get that moisture content. And moisture contents are relatively inexpensive tests. The thing I want to mention about the geology too, when you're writing your report and you're talking about geology, the site has glacial soils. Really, my mother-in-law could have told you that, having been around me for 50 years. Okay. But glacial soils, was it glacial outwash? Was it glacial lacustrine? Was it a over-consolidated glacial till? Those are the parts you have to start getting into the details of the geology and not just make some very generic statement. And you start reading these articles about writing soil reports that were started back in the 50s, 60s, 70 years ago already. They talk about the importance of geology. Anybody who knows who Carl Terzaghi was? Greg, I know you do. Okay. Okay, Carl Terzaghi, he's the godfather. I mean, he's the guy who started it all. What was his first degree in?
Geology.
Geology. What was his second degree? Pardon? Mechanical engineering. What was his PhD in? Structural mechanics. He never had a degree in geotechnical engineering, and he's the godfather. The guy was brilliant to put all of this together. But he made the comment in his books that in order to understand how a soil behaves, you have to understand how it got there. That's part of what we geotechs have to do, and explaining that in a report will provide more clarity. Maybe the readers won't fully understand what you're saying, but that's okay as long as you've written it clearly so that it can be understood. That's not a problem to understand that part. But just saying it's glacial soils, that's not enough. There's more to it than that, because different glacial soils behave differently. Even the same layer of a glacial soil might behave differently in one part of an area than another. These are things you have to know. But that's a good question about say part of it is studying what you can about the geology. Another thing you can do on that case like that, and I've done this, is going into the suburbs, into the engineering department, ask if they have any soil reports adjacent to the site. I've done that. I know Eden Prairie, I've gotten reports from Eden Prairie that were done in 1976. On the other hand, the city of St. Paul, I understand, throws out everything after 2 years. Okay. So there's no set pattern, but it's an opportunity to explore and find out where are these questions? What do we have in the area? But that other one about having maps within a given corporation, maps of where you've done work, so that young people can go in and look at that map, even if they're not old timers not around, say, did we drill anything close to here? And get an idea of what's there. I hope that helps out a bit on what to do. I mean, there's no absolute answer, but it's like building a brick wall. You do it a block at a time, you know? Anything else? Comments, questions? Anything else you want to know about that I can try to answer for you? Somebody's phone just beeped. Yes, sir.
From your experience, where have you seen the most issues? In what part of the geotech report? Is it the discussion, or is it the analysis? Is it the recommendations?
I'd say it comes out more in a good part of it is the failure to include discussion. Like not discussing what the groundwater is really going to do to that building, or not discussing constructability issues on sensitive soils, or not warning them. You know, there are textbooks being written today, by the way, on how to park cranes and how to analyze the crane stresses on soils. I've been an expert in a number of crane cases too. This stuff wasn't a problem 20 years ago. I mean, the cranes were there, but all of a sudden, if a lawyer can make a case out of it, he will make a case out of it. But I'd say it almost comes more to, when you make me think about it, of failure to discuss things that were there rather than by a specific recommendation of what to do. You know, it's not too often that a geotech's going to give a out of whack bearing pressure. I mean, you're not going to say use 25,000 pounds per square foot on, you know, on a 4 below sand. You're just not going to do that. But I got to tell you, see the Menard hat. Louis Menard wrote his master's thesis at the University of London in 1957 on the pressure meter. You need a copy of it, call me. When I tell you, I've got all these old papers and articles. Now I've got that copy. My wife says there, why do you keep this stuff? And he said, because, you know, somebody might ask for it someday. And you might have to have it. Yes, sir.
Bill, what can you speak to clearly communicating to your drilling staff as to what you need to clearly write your report?
I'm sorry, what
What can you speak to as far as clearly communicating with your tax and your drilling staff, get you the information, write your report?
I touch on it briefly, but I'll go into it more. You know, there's what we'll call as a routine job. Area of good soil conditions, putting up a Burger King. What can go wrong, right? You start getting, the more you start deviating away from a standard job under known soil conditions, the drill crews, and having worked on a drill crew and having run drill crews, I have a good understanding of this. They will tend to treat things routinely unless you advise them that this is special. Okay. And that's one of the reasons I mentioned we started sending out our drill crews with a couple of piezometer plastic pipes, just in case they had to throw a monitoring well in. You know, this idea that, well, we hit groundwater in 13 feet in the boring, and we didn't have time to monitor in the long term, and putting in monitoring wells was beyond our scope of service. But they called in and the crew's already told the project engineer, we got muddled soils at 5 feet. That's a clue there, right? Shallow groundwater. You call the client and say, look, we're at the site. It only costs $150 to drop this piezometer. And right now we can monitor the groundwater table for the next month or so. The crew's got that. It makes it easier for you to do a thorough job instead of just saying it was beyond our scope of service. Oh, by the way, if you utter that phrase, yeah, putting in piezometers was beyond our scope of service, that won't get you too far in a deposition or a court. I've heard that one. Okay, but it's being ready for perhaps the extraordinary, in a sense, you know, and getting, another part is getting the crews ready too, that, you know, if they're in poor soils at the bottom of the 25-footer, I had my crews just go an extra 10 feet before they call back in, so it could see what happened. But getting them the idea of working with you, that we're not just out there to make a hole, we're out there to get samples that we can use to do this analysis, because your analysis is based on in good part on the quality of the samples you get. Okay. Have I addressed your question well enough? Okay. If I haven't, we'll start over again. Any other questions? Comments? Oh, yes, sir.
Online. What is your best advice to mid-level engineers training new engineers about writing good reports?
Good question. First thing, again, I would have them get some of these textbooks that I referred to up here. Let's see if we can go back on this. Yeah, it doesn't want to go back. Yeah, go back to get the. Okay, some of these books are. I first of all, I'd say get some young engineers some of these textbooks, the Grammar Bible, the Well-Tempered Sentence, punctuate it right. What else we got here? And by the way, these are books that the engineers. This is stuff you read at home. Oh, here's a good one. Eat, Shoots, and Leaves. Anybody know the source of that book? Okay, it was written by an English teacher in England. It's a history of the English language. So the title comes from a fellow sitting in a bar, drinking a beer, and a panda walks in. Panda walks over to the bar, sits down, orders a hamburger, orders a beer, finishes it, pulls out a pistol, puts a couple rounds to the ceiling and walks out. And the other guy turns to the bartender and says, "What the heck was that?" He said, "Oh, that was a panda. It's a marsupial from China that eats, shoots, and leaves." Where you put the commas, change the context, the whole context of the word. Up on the top, most common errors in English usage, how to avoid them. Throw mama from a train, right? A kiss. There's things you have to be careful of in writing English that can be misinterpreted. So my first advice would be to get some good basic textbooks. Writing for Business by Steve Wilbers. He's great. He's great. Get them and assign them to the engineer, the developing engineer, to read, one a month or something like that. But because it's difficult to sit there and go back and be an English teacher when you're trying to teach somebody geotechnics. But it is part and parcel of writing a good, comprehensive, easily understood report is to write well. Have I addressed the question for you?
I think so.
Okay.
He was asked online.
You can see I've got a whole bunch of pictures about these books up here, don't I? Oops, won't move again. Move it back up one. Can you click it back up one? Punctuator, how to write a sentence, the Grammar Bible, the Well-Tempered Sentence. I mean, American English in particular, has a lot of quirks about it. And you have to learn about these to avoid getting caught in your writing, misinterpretations. There's another one I've seen where it's one geotech engineering firm tended to use, if they wanted to put 1 foot, they put one with the foot mark on it. And somehow something got mixed up, said 1 foot should have been 1 inch. Just spell it out, 1 foot. Because one of the rules here is that if it can be misunderstood, it will be misunderstood. And you got to look at this. And again, the way I say this, I have to be careful with my friends who are attorneys. You have to consider the attorney. Remember, I told you that this is a projection of you. And when you're being can be understood when you're not physically present. I say, this is an attorney's reading your report at 10:30 on a Saturday night, and you're not there. You have to write it so he has no questions. Okay. So, and if it's a difficult concept to understand, take the time to give a further explanation about it. Don't assume that the reader will necessarily understand it. What we deal with is some arcane, esoteric stuff. Okay? Any other questions, comments? Yes, Doug.
I'd like to drill into the whole concept about writing style and stuff a little more. And I remember one project where I got involved with a colonel and the office of counsel and a whole bunch of other people, and even office of counsel was flipping things back and forth, and we rewrote a document about 10 times that was unrecognizable from its original version before it got signed and went out the door. And it was enlightening to me how, if you critique your own and everybody else's writing, you can really improve things a lot.
Mhm.
But I've also got involved in a lot of controversy, like what's the right way to write. I remember another project I was on where there's a historian and a contracting official. they're both very high senior level people, well above my pay grade, and they thought, oh, they were reviewing each other's work, and they did not agree at all. So how do you approach this when somebody says, I don't like your writing style? And we have us in the geotechnical profession have kind of a distinct writing style as opposed to other communities.
Here's how I'll try to answer that. You notice that one of the things I mentioned is avoid the use of the passive voice. In technical writing, that is now recommended. Academics like to use the passive voice because, it's impersonal and you're not injecting I and me into it. But there's two problems in technical writing with the passive voice. One is the doer of the action is unknown. It is recommended that you use 3,000 pounds per square foot. Who recommended that? My mother-in-law? No, we recommend you do that. Take responsibility for it. The other problem is the doer of the action is unimportant. Now, if you're the geotechnical engineer in the job, would you consider yourself unimportant and use the passive voice? Now, if Ernest Hemingway wants to use the passive voice in The Old Man in the Sea, he's free to do it. I don't care. Let him win the Pulitzer Prize for doing that or the Nobel Prize. But in technical writing, I think some of that complaint about the different styles could be overcome by following some of these rules. Again, subject-verb agreement, avoid the passive voice, proper punctuation, the proper placement of words in a sentence. And if two people are disagreeing that much, I'd sit them down and start talking to them, saying, what do you object to in the style? Is it word usage? To find out what is the specific. Again, we're not writing novels here. We're writing things that are presenting technical data in a way that can be technical data that is not well understood by many of the people who have to use it. One of the things I've asked, I set up a question for a civil engineer in a deposition. And Mr. Civil Engineer said, in your report, you use the standard proctor. And then next page, you use the modified proctor. Have you ever read standard and modified proctor? ASTM standards? No, he hadn't. Can you tell us the difference between the two? No, he couldn't. That's the audience you're writing to. Okay. So
one of the primary criteria is looking for things that could be misunderstood.
yes, sir. That's a good way of explaining it. You have to look at the things. Take somewhat of a dispassionate view. I even go back and read reports I wrote 25 years ago. It's like, gee, how did I say that? That I didn't write that really clearly. I mean, if I can do that after that period of time, but to go back and read some of your own writing and say, did I explain that in a way that I believe my readers could understand it? And then proceed from there. But if two people have conflicts, look at your next one. If two people have conflicts over style, the style is word usage, which word, you say potato, I say potato type thing. That's not going to clear up the issue. Because we're really talking about turnips, Okay. Yes, sir.
But going to what you just said, does that ever end? Could you read your report over and over again and find different things each time?
Have I read my reports over?
I'm just saying, you said you read what you wrote
Yeah.
25 years ago and you didn't like what you said. If
I
you read
didn't
that
like the way
a month from now, do you think you'd find something different?
I didn't like the way I said it.
Okay.
I was okay with what I said,
Okay.
but I didn't like the way I said it. I could have written it. Even then I said, I could have written that more clearly. And then
What do you find within yourself when you write that clearly then? Are you good with that? Or do you think you'd change your mind?
this is the job that's already up. But the thing is, even take some of the stuff, take a report a month after you've sent it and go back and read it. And don't do it at the office. Take it at home. Sit down with a glass of wine or a beer, after the kids go to bed. Sit there and say, I'm going to start going through this with a ballpoint pen, a yellow marker. Start saying, did I really write this as clearly as I should? At one time, I even gave some of my reports to my wife and had her read them. She's an RN. I mean, she's not an engineer. To see if she could understand what I'm saying. Some of the stuff she was able to understand to follow me. But it's, like I say, from what I've seen, when you get into a court of law, and that's what so much of this has just driven me now, the idea that in today's construction environment, well, by the way, I should mention this, as I understand it, the three driving forces in terms of litigation are fast track construction, roofing, and soils. Those are the three top elements that lead to litigation in construction. And then, there's another thing that we didn't even have, like when us old guys started doing this stuff, the geotechnical baseline report, the geotechnical information report. I mean, now they're dividing the report in 4 different categories. And you have to decide which one we want. And that came about primarily for legal issues. Was the report included in the contract, and the contractor relied on it? And those become very difficult questions to answer, whether or not the contractor can rely on a report. And so they've tried to come up with these different types of geotechnical reports. And I just bought another textbook on the geotechnical baseline report. And I'm highlighting it, marking it, and reading it to say what do they mean? But in your day-to-day reports, you don't get involved in that when you're just writing a geotech report, but there are these different types. But again, go back to what you've read, even take one of your proposals and read backwards. Did you really define the project clearly? There'll be a 4-story building of steel frame construction, 1 basement, 10 feet deep, maximum column loads estimated to be 350 kips. And see if you explain that clearly, or did you say, well, it'll be lightly loaded. There'll be several feet of excavation. There'll be light traffic on the pavement. Okay, and try to get away from those nebulous terms and just get definitive. It takes no more effort to put a definitive term in. The pavement will be designed for, 30,000 easels a year, and it's going to be open all year round. And that's the way it's going to be. But be more definitive. Yes, sir.
You made a comment earlier on the length of report.
Yes.
I've seen geotech reports that are 12 pages long.
Mm-hmm.
I've seen geotech reports that are 150 pages long. And that 150 page report, probably 130 of it is CYA language.
Yep.
Can you comment on the validity of needing that material or not needing that material and why it's there? When we're talking about litigation and things like that?
I would submit that, it depends on the complexity of the job too.
Sure.
Okay. If you're running a soil report for nuclear power plant, maybe 150 pages is worthwhile. Okay.
Potentially valid.
If you're doing it for a 3 or 4 story office building, I would submit it's not. I would, from my review of these things, if a geotechnical engineer gets too verbose, starts to write too much, what happens to the reader? Click. And they just start disregarding what you're saying. Okay. Especially if you get too repetitive. Although sometimes you have to tell them what you told them, tell them again, just to make sure. But I mean, you can't be too verbose, but you have to explain it clearly. And if you're to the point, and that's not a reason for doing an outline too. If you can keep on a steady developmental track that you're developing the parts of the report in a logical sequence, I submit that will probably help you shorten things up. There's one cartoon I've used in this talk I give about how to write a soil report of the family circus, Bill Keane. Have you ever heard this? And mom says, Billy, I need something from the store right away. Can you get there quickly? They're going to close. So he says, yes, Mom. He takes the money from her in the shopping list. He goes to the grocery store. He comes back an hour later and she says, where were you? He says, I came right home. And Bill Keane is famous for this in his cartoons, the dotted line. It goes all over the neighborhood before he gets home. I've read reports like that. Like, my gosh, I know what he's talking about and I can't understand it. That is one of my judging points, by the way. If I can't understand a soil report, I'm telling you, the structural, the civil, the construction manager, the architect, they're not going to understand it. But that's a good point. If it gets too verbose, it gets to be that long, unless the complexity of the project warrants it. And even then, there should be divisions in the report to break it up as to what is being talked about. Realistically, an earthwork contractor isn't that interested in the bearing pressure because he's not going to be using that. But he's interested in the constructability. Is that soil too wet or too dry to use? Are there some quirks about that soil in terms of using it as a compacted fill? If you had that broken out in a report, you'll get there and read it.
Well, yeah.
Yep.
There's certain sections of the report that mean a lot to me. There's certain
Yep.
sections of the report that.
But it's the fact that there's still questions there, no matter how much we learn about this. I mean, and I had to answer this one of my litigation cases. Mr. Kwasny, how many soil reports have you written? Over 5,000. How many have you reviewed? Well, within the companies I worked in, I've reviewed and co-signed over 10,000. I've been involved in national peer review programs with ASFE. I've done peer reviews for developers and contractors. So you know a thing or two about writing soil report. Yeah, I think I know a thing or two about it. And even then, I'm still learning. You know, how to make these things clearer and more easily read so that you don't have you want to talk about writing for somebody, you start writing these technical reports for an attorney who's got a degree in political science. I mean, now that's going something. You have to explain that one. Okay. Any other questions? Come on, this is the time. If you're here, we'll keep taking them. Okay. 10, 9, 8, 7. No more questions online. Well, thank you for being here and thank you for your attention.